Good morning, everyone. Welcome to the plenary talk of mathematics education. I'm Raquel Dor. I'm a member of the Mathematics Education and Research Group from the Mathematics Department of the University of Brasilia. And before the beginning of this plenary talk, I would like to introduce you to Professor Alessandro Ribeiro. Alessandro is professor from the Federal University of ABC, São Paulo. He's chair of a research group whose main area of investigation is the mathematics teachers formation. Today, he will be taking part in the moderation after the talk. Alessandro, thank you for joining.
Thank you, Raquel. I would like to thank you and all the organization committee for this invitation. I hope everyone has a very interesting talk today. Professor Alf Wallace is a very known mathematics education in the world, and I am sure we will have a very good morning in the working. Okay, so thank you, Raquel, for this opportunity, and I hope all of you can enjoy us.
Now I'm honored to introduce you to Professor Alf Coles. He's a professor of mathematics education in the School of Education at Bristol University. Some of his areas of interest are teacher development, ways of working with video, listening and hearing in the mathematics classroom, Euler number, and creativity in the classroom. Today, he will be speaking about the need for an ecological turn in mathematics education. Professor Alf, we thank you for accepting our invitation and we welcome you to this plenary.
Thank you very much, Professor Raquel, Professor Alessandro. It's a great honor to be here. So thank you very much for inviting me and to the organizing committee. And I hope that what I have to offer will be of some interest. That there is a phrase in England, now for something completely different. So if you were in the first plenary, I think this will be true now. This might be completely different to what you've just done, but I hope it will be of interest. And I will aim to leave around 10 minutes at the end for questions. And please feel free as an audience to write your questions in Portuguese. And we have some people who are able to translate in the chat, which will be great. So thank you very much. Okay, so I want to talk today about an ecological or maybe socio-ecological turn in mathematics education. And I hope that there might be some resonance of what I am talking about to your context and your teaching. So there will be three parts to this talk. First of all, talking about this movement, or at the very beginning as I see it, I have an example of some work I am engaged in with a group in Mexico. And finally, some reflections on what this might mean for your teaching in any level at school or at university. Okay, so a socio-ecological turn. And I put a question mark there because this is not widespread at the moment. But I feel there is growing awareness of ecological precarity amongst mathematics educators, which has provoked a questioning really about what is the purpose of mathematics education? What kind of world are we leaving students, and what kind of skills will they need for this world, and how might mathematics education contribute to that? While a body of research and scholarship within mathematics education has been developing for a long time around political, socio-political issues, the world, the environment, ecology has largely been neglected. One important thing I want to say at the beginning is in England, where I am from, I hear a lot the idea that there is a crisis now, an ecological crisis. And I want to try and avoid this word. I don't always succeed. Recognizing that while this precarity, precariousness may be new in parts of the global north, including England, that feeling that life is precarious is not a new experience to marginalized groups from around the world. And this seems an important point. And the phrase socio-ecological points to a desire to think about the human and non-human together. So what has really been happening, I feel, up to this point, and is only slowly changing, is that human concerns have been seen as quite separate to the concerns of the planet. And if there is anything that climate change, COVID has shown us, it's that we can no longer separate thinking about the human and the non-human. There has been some work within mathematics education addressing issues of sustainability. In 2010, Renner offered some approaches, and I just offer these in case they might be interesting for you to think about in terms of your own teaching and work. So Renner suggested there were 3 ways to approach issues of sustainability. One approach he called the accommodation approach, where sustainability issues are maybe the context for teaching mathematical skills. So perhaps statistical skills are taught using climate data, but maybe there is not a further engagement in the implications of that data. Moving on, a second approach he classified as a reformation approach. So some critical thinking and discussion of values being included in the learning of mathematics. So perhaps discussion about the causes of climate change and its implications. If I think in England, there is maybe quite a bit of work around accommodation going on and beginning to be some reformation work. But I think almost no work in schooling or universities that I would call a transformation approach. And here, for Renner, the teaching and learning of mathematics becomes subordinate to a process of students becoming engaged as critical citizens, using their work in mathematics, students critiquing the status quo and participating in social action. In fact, in England, the government is quite clear about not wanting schools and teachers to engage children as in a politically active way. There are some other strands of related work, and I will just touch on these briefly. D'Ambrosio, who maybe I'm sure many of you will know, highlights the role of ethnomathematics in the pursuit of peace, which I would see as an element of a transformation approach. Interestingly, within ethnomathematics, there is not much focus in the writing that has happened so far on the environment or on ecology. There are several writers talking about the idea of eco-justice, and also a very strong strand within mathematics as well of socially just teaching, thinking about improving opportunities and outcomes for those who experience injustice, and also touching on this transformation of structures outside school. Critical mathematics education, again, Ola Skovsmasa, who has spent a lot of time in Brazil, I'm sure is familiar to many of you. Again, his work perhaps not directly speaking to ecological issues, except perhaps more recently, and also some helpful frameworks around anti-oppressive education. So to summarize this first part of the talk, thinking about this ecological turn in mathematics, one of the things that is raised up in question is that mathematics emerges from this literature as far from neutral. Mathematics very clearly has a role in the modeling, description, analysis, communication, and even creation of global challenges. And this role is a role linked to human decisions by actors with their own agenda. And so one clear implication of this as mathematics educators is a question of how much we want to point to this human side, perhaps, of mathematics, or political side of mathematics. How much do we want to raise questions about the values involved in mathematics. There are newspaper articles around algorithms used now for deciding who goes to jobs, job applications. Police are increasingly using algorithms to decide where to deploy police people. And some of these algorithms have biases built into them. Again, a sense of mathematics actually creating some issues from the models that it uses. My colleague Mark Boylan and I conducted a review of mathematics education work that had some socio-ecological aspect to it. And we have proposed 4 categories, and this is really my final point on this, looking at a socio-ecological turn in mathematics education. And we have suggested there are 4 approaches, and we are not suggesting one is better than the other. So if you were interested in thinking about questions of ecology in your own teaching, we hope this framework might help you think about possibilities for doing that. A mathematics education about the living world, for the living world, with the living world, or as the living world. In the first category, a sense of focusing on individuals, individual actions and responsibilities. And there is important work that needs to be done there. Education for the living world, touching on issues of social justice bound up in ecological issues. And that relates to the example I'm going to be showing you on the next slides. Education with the living world, perhaps linking to these ideas of transformation, critical approaches, social transformation. But we also have noticed quite a recent trend of work, which we are calling education as the living world, which is really a kind of post-critical response, which is doing this work of trying to stop putting humans at the center of all of our attention, and humans not being the unique ethical actors, to trying to rethink what mathematics is or what it could be, and thinking about humans and ecology, not just from a human perspective. And that's hard work to do. Okay, so I hope that has set the scene for some currents of work that are going on, which I feel are very important and I feel will be gaining momentum in the coming years. I feel that there's increasing interest around these ideas. I want to talk to you now about an example of a community-based project in Mexico where we have tried to do this work of linking up the human concerns and ecological concerns. And I'm very grateful to Armando Solares from Mexico City, and I've adapted some of his slides in this bit of the presentation. So the project I'm going to talk about has this name: Community Science and Education, an interdisciplinary perspective for facing ecological crisis in Mexico and South America. So you see, I'm not able to always avoid talking about crisis. This is work that is hosted at Sinvastav in Mexico, with collaboration with the University of Bristol, the National University of Mexico, and the non-governmental organization of the Centro Fray Julián. It is funded by the UK's Research and Innovation Council, and on the bottom right, you will see the logo of this project. The context of this work is the Atoyak river basin and its communities. And this is an area in Mexico. We are also linked into a project funded by the World Universities Network. World Universities Network, yes. And that is a project involving 8 universities across the world, linked as you see here. I'm going to be talking today about the work taking place in Mexico, and in particular in the area Tlaxcala state in Mexico, and that's where you see where it is. This is a state with a rich heritage in pre-colonial times, with Mayan communities there, and a very rich cultural heritage which the community is very proud of and is captured in murals here, for example, in the state capital. So the place where this work is taking place is the river basin of the Atoyak. This used to be a very fertile area. That lake there on the topographical map, that lake has now disappeared. But here is a reconstruction of that lake in pre-colonial times, where the water was very central to the community. And still there are some areas where you can see remnants of this kind of way of life. Now the Atoyak River Basin is an area of industry, and there are a number of industries that have grown up there. There you see the catchment area of the Atoyak River. And one of the reasons why we have focused work there is because of the state of this river today. So the photographs I'm now going to show you are taken by project members. So these are current photographs of the state of the river. When I first visited this river, I saw a site a little bit like this. And it's a little bit hard to see, this almost could be a healthy river, I think. The color looks, I've seen rivers in England looking a bit like this. When you look a bit closer, you see that nothing is breaking the surface. There are no fish in this river. The fish left 30 years ago. In fact, there are not even insects on this river. And the reason for this is that into this river come the outlets from all the industries that I was showing you on a previous slide. So this outlet here is from a German car parts factory, which is regularly sending illegal heavy metals into this river. There is an Italian fashion factory which dyes clothes, and the outflow from this factory is blue. In some cases, as you see in that image, sometimes it's red, sometimes it's purple. And the result is a river that is, I would say, dead, has no life in it. It's a river that used to sustain the community that it served, and is now a dumping ground and a place where the smell is so bad that even 1 mile away from the river, you can still smell, you could still smell it. And of course, this is a situation that has very severe health implications. Here is a map of the incidence of various cancers, renal deficiencies, abortions, and miscarriages. And you can see that the prevalence of these diseases almost follows the river course. You can almost plot the river by seeing where these diseases are at its highest. And the groups that are most susceptible to these diseases are, of course, children and elders. There has been a very engaged community fighting for the health of the river over a number of years. They have had high-level representation in members of the Mexican government, members of the EU coming to visit, all agreeing that this situation is appalling. The group I feel privileged to be part of is linking this community group with scientists who have been working in the river for many, many years, and educators who are linked to the local schools. Because in the local schools, what we find is that there is very little attention to the river in the curriculum. So in Mexico, there is a very centralized national curriculum. And when they deal with issues like pollution, in the textbook, you have issues like recycling in Mexico City. So here is a situation where children can smell this river from their playground, but it is not really dealt with in great detail in their curriculum. And this is really the central issue that this project is aiming to address. And what has emerged as the idea of this project is to set up a memorial school project, Atoyak River Memorial School Project, which will have 3 components to it. The first component is a recapturing of the history of this river. Because it has been polluted for so long, many children, all the children, and even many teachers have never known the river to be healthy. So one aspect of this memorial project is to recover some of the history of what this river used to be like. The second component is, so if the first one is about the past, the second component is about the present. What is this river like? What are the processes by which it is being contaminated? And how is this changing day to day, month to month, year to year? And the third aspect is looking forward to the recovery process. So I'll say a little bit more about each of these things. So it's like there will be 3 galleries is the idea. And we are hoping that this is ongoing work. We've done the planning, but the work has not taken place yet. But we were hoping these will be physical galleries in the schools in those local communities. So the first one, as I say, looking back, once upon a time, a river, reconstructing the memory and identity of the community in relation to this environment, with some ideas there about how to go about it, thinking about what was the river like, what did community members do around the river, what kinds of plants and animals inhabited it. The second gallery, talking about the Atoyak River contamination. It's quite shocking. I saw exactly this site of this image. I don't know if you can see there. You can just make out that the channel coming into the river is carrying the blue dye from one of the factories, and you can see it mixing there with the brown of the river, and you can see the difference there. So looking at the current state of the river, what pollution is there? Who is polluting? How do they pollute? Because, of course, this is all illegal. It has been going on for decades. It should not be happening. The protections are there in law, but they are not implemented. And the third gallery, thinking forward, children's rights to a healthy and toxic-free environment, trying to support the students knowing their universal rights and exercising them with a number of possible ideas. Some of the project ideas from the teachers that link to different galleries are to think about solid and toxic waste management, the labeling of products, trying to recapture the memory and oral history of the community, maybe a photographic memory, and some ideas around participatory mapping of the community. So this is all work that is taking place. We would be very interested in linking to other groups and communities across South America who are engaging or would be interested in engaging in similar work. So if you would like to find out more or to get in touch, we would love to hear from you. The principal investigator is Amanda Solares from Simvastav in Mexico City. He is very happy to be contacted directly, as I would be also. Because one of the ideas of the network is to begin working with the Atoyak community and to try and learn from that experience and try and take that learning to supporting other communities. Really, the key question is, how can the curriculum become relevant to the needs of that community, to the lived needs of that community in the ecological situation that they are in? Okay, so that concludes the second part of the talk. And now for around about 20 minutes, I hope the last 20 minutes, I'm going to be touching on perhaps broader issues of preparing for a future that is not what it was, perhaps. It seems to me, if I think now about the next 10 or 20 years, it's not what I thought it was going to be when I was young. And I want to end this talk with some thoughts about what might be possible within a standard mathematics curriculum. So the work I've just described in Mexico is intensive work. It has required a lot of community building with communities that have been working there, with scientists, with schools. It's such important work, and it's very complex. And of course, it's not going to be possible in all situations where mathematics is being taught. So I want to think about what other things might be possible to do in a standard curriculum in a school or a university. Of course, mathematics brings skills like analytical thinking and problem solving, which are very helpful for students. But I want to argue also that mathematics can offer students experiences of their own agency, and that this is particularly powerful in the context of mathematics because mathematics is often seen as a subject where I have very little agency. And by agency, I mean things like being able to ask my own questions and follow them through, being able to choose my own methods of representing mathematics. I want to draw here on work I've done with Professor Natalie Sinclair from Simon Fraser University in Canada. One of the things we have been written about is the idea of rituals and ritualization in mathematics. So learning mathematics is sometimes thought of quite negatively as being highly ritualized. Rituals here being associated with unthinking action. So I'm thinking here of examples of classrooms where there's maybe a lot of repetition. So it's like the learning becomes almost like a ritual where I don't have to think about it. I see an equation or I see a calculation and I just do the algorithm without thinking about it. And what Natalie Sinclair and I have been writing about is trying to think about not ritual, which splits up action and thought, but thinking about ritualization as maybe a helpful concept for mathematics education, where ritualization is a way of acting designed and orchestrated to distinguish and privilege what's being done in comparison to other activities. So ritualization is a matter of various culturally specific strategies for setting some activities off from others, creating and privileging a qualitative distinction between the sacred and the profane. And perhaps there could be some sacred elements, perhaps, to the learning of mathematics. And what seems helpful about this idea of ritualization is it's not set opposite to thinking, but rather it's a form of thinking, maybe a form of non-discursive thinking. So Catherine Bell, who we have been drawing on, writes that ritualization is embedded within the dynamics of the body, defined within a symbolically structured environment. Ritualization is a particularly mute form of activity designed to do what it does without bringing what it's doing across the threshold of discourse or systematic thinking. So with Catherine Bell, I resist making the jump from acknowledging something does not cross the threshold of discourse or thinking to assuming it's therefore meaningless or unthinking. And I want to suggest through 2 or 3 examples that ritualization may be a helpful concept for thinking about teaching and learning mathematics, where maybe we are interested in how children might gain a sense of their own agency in relation to learning. So symbolically structured environments in a mathematics classroom are ones where Natalie and I have suggested there are the following features, and I'm going to illustrate these in a moment. Symbols being offered to stand for actions or distinctions. Symbol use being governed by rules or constraints embedded in the structuring environment. Symbols being immediately able to be linked to their inverse. Environments where complexity can be constrained, but where you can still engage with a mathematically integral and whole environment. And crucially, environments where novel symbolic moves can be made. And this is where really the link to students feeling they have some power over mathematics comes in. Here is an example from my school teaching that perhaps could also be relevant at university level. And this was a write-up that I wrote for other teachers in my school, based on an idea from the educator Lorinda Brown. And this was the idea to engage school children in thinking about matrices and transformations. So here were the instructions to the teacher. This is almost like the lesson plan. Draw a coordinate grid in your book. Well, that would be the instructions for the children. And to get the children to draw the shape exactly as I've done there. So what is it? I can't see the chat now. If I could see the chat, maybe I'd ask you to see what you see there. Children often in England think it's a church, which is great. So then the idea here is to explain to the children that what we are going to do is we are going to make a transformation of this shape using this particular matrix. When I was in school, the film The Matrix had just come out, which was when I was teaching in school, which was a helpful link here. So this is a matrix that is going to transform our reality. So I would then, as a teacher, support the children in performing a matrix transformation on each point of the church, taking the coordinates one by one, writing the coordinates horizontally. So 1, 5 would be the top of the point of the church. Following through the matrix transformation, it becomes 7, 5. So that is the new peak of the church. Repeating those instructions every time, the children are able to transform the church. I'm not at this stage explaining much except how to do this multiplication. I'm not saying why the multiplication works as it does. And this is maybe the ritualization aspect, that this is just the process. You have to do this. This is how it's defined. And we're not going to discuss why it's defined like this. So we do this process. But what emerges out of that is that as a student, I see now this new shape of the church. I can see that it's done some things. And it's an obvious question to think about, how have the numbers in the matrix changed it in this way? And a challenge we would give to our children is, okay, in 5 lessons time, I will come in, write a set of 4 numbers, a matrix on the board, and your task will be to tell me what is the geometric effect it will have just by looking at those numbers. So children are then able to go off. Maybe someone tries 3, 0, 1, 1 and sees what effect that has. Maybe someone tries some different sets of matrices. We would encourage children to do their work on paper and to put this paper on the wall, so they could very quickly get a big collection of graphs and their matrices. So all the children can see the work of each other and can start to notice patterns. What does this matrix do? What does this matrix do? Can we start grouping them? After a while, the inverse question might be thought about. Well, we know some geometrical transformations, such as enlargements. What matrix might create an enlargement? This work has all the features of a symbolically structured environment. The symbols of the matrix, 2, 0, 1, 1 in this case, are introduced in the context of a transformation, an action. So students can see this matrix doing something. The symbol use is governed by very strict rules and constraints on the environment. There is only one way to multiply a point by a matrix, and if any student does it differently, that's not what we are investigating in this task. You have to follow this rule. Symbols can immediately be linked to their inverse. It's a very obvious question to ask once a transformation has been done one way, what would be the matrix that would return the shape to what it started from? Complexity can be constrained with some groups. Maybe you could suggest that there are 2 zeros in the matrices that they look at to begin with. And importantly, novel symbolic moves can be made. Children are free to choose their own matrix to try out. They can choose their own shape as a starting point. Okay. So here is one example of a symbolically structured environment. matrices and transformations might appear at different stages across the world. When I was in school, we would do this work with 14-year-old children, not because matrices was on the curriculum, but because this task would get them doing all sorts of geometrical transformations. It would get them doing lots of coordinate work. It would get them doing lots of multiplication practice. So it was a context where lots of curriculum aims could be met. And because those were our aims, we didn't mind which matrices they looked at, because almost anything they did would be meeting our aims of thinking about transformations, thinking about coordinates, and so on. So here's a second example, maybe more of a university level one. How might you introduce complex numbers as a symbolically structured environment? Well, again, what I used to do at school, so in England, this would be a topic for 18-year-olds or 17-year-olds. What we did at school is we would set up that what a complex number does is it performs a transformation on the Argand diagram. I don't know my audience, so I hope Argand diagram is meaningful to everyone. I know it will be for many. If it's not, I'll go quickly through this example, and I have one more. So the complex number 2z can be interpreted as a transformation of the Argand diagram, enlarging this, in this case, a unit circle by 2. So we might invite students to consider other geometrical, consider what geometrical transformations are represented by any of these complex numbers. Given any complex number, can you predict the geometrical transformation it will, or given any function on a complex number, can you predict the geometrical transformation it will provoke? And again, this kind of task has all the elements of a symbolically structured environment. Complex numbers themselves stand for transformations, actions. Again, there are very clear rules about, and these would need to be introduced, about what it means to transform coordinates with a complex number. Issues of the inverse, constraining complexity, and again, novel symbolic moves being able to be made. I did have one other example. I'm wondering if we've got time for this. If I, okay, maybe we have. So some of you may know Eulers' formula that the vertices, faces, and edges of a shape often fit in a certain pattern. So this is an example maybe more for school, and I want to show you, suggest there might be 3 ways of approaching this task. So I might give a class this formula, and I might give them a whole load of shapes, and I might ask them to check the formula works. This might be one way of doing it. I give you the formula, and I ask you to check it for shapes. And there could be very useful learning that comes out of that. Another approach is maybe I could give you lots of shapes and ask you to investigate them. And maybe I could hope that you might come up with the formula. If you're interested in a symbolically structured environment, you would do something a bit different. And I'm going to escape from the whole view so that maybe I can see the chat as well here. So let's start with a cube. Could somebody in the chat tell me how many vertices has a cube got? Maybe you could put that in the chat. I don't know whether I can see the chat, actually. I'll see if I can. So could somebody put how many vertices in a cube, how many edges, and how many faces? So the vertices are the corners. So I'm wondering if someone can do that. Maybe you're doing it and I can't see, I'm not sure. Hopefully we would agree there are 8 vertices in a cube. How many faces on a cube? There are 6. And how many edges? Is 12. If I perform this calculation, vertices, they're coming, thank you. Yes, lovely, brilliant, you're there. So now if I perform this calculation, vertices plus edges, plus faces minus edges, please could you type in what is the total I get there? Maybe I shouldn't ask you that question. I think that one's an easy one, isn't it? Okay, where I do need a question from you now is, okay, so we've got 2 here. So please, can someone in the chat, could you suggest a second shape we could look at? So we've looked at a cube there. Please, could somebody suggest a second shape? And I will pause a moment here to see if someone can do that. And it's no problem if it's delayed because, yes, fantastic. Thank you. Edges is 12, beautiful. Maybe there's a delay. I think maybe there may be a delay in the chat coming through. Well, I'll tell you what happens in a classroom is that almost pyramid, lovely, thank you. Okay, so let's do 2 then. So because in a classroom, what often happens? Oh no, we'll do pyramid first. We'll do pyramid first. So let's take a pyramid. So if we have a triangular pyramid, perfect. So the vertices I think is 4. The faces, I think, is 4. And the edges, I think, should be 6. So we should get the total 2 again. Now, I need another line underneath this. Can I quickly add that in? Okay, I'm going to write over it because I should have had more lines on my table. A question that often comes up in the classroom is a sphere. And maybe you'd think we couldn't do this with a sphere, but a sphere, well, perhaps it has no vertices. Not sure what we mean now by vertices. Perhaps it has no one face, sorry, and perhaps it has no edges. So now this number comes to 1. Now we have 3 examples here, our cube, our sphere, and our pyramid. And it's a very obvious thing, I think, now to ask some questions. So at this point in a classroom, I have constrained what is going on. We know we are looking at vertices, faces, edges. We have set up this situation, and now it can open up. So what questions might you ask? Well, very natural questions for the class are, well, which shapes come to 2? Which shapes come to 1? Some people might ask, well, what do we mean by a vertex? This can lead to children exploring their own ideas. Again, work can be gathered together. It can be looked at all together. And it can lead to some very interesting elements of mathematics. What we find is that when we design a symbolically structured environment well, is that students become highly engaged because they become interested in asking their own questions and working on those questions. We find that their learning is energetic and rapid. And if we've designed it well, then really the students can explore anything they're interested in because it will be meeting our aims for that topic. It's possible for students to collaborate across widely different levels of prior attainment, especially if there is some mechanism for the common collection of their responses. So for instance, looking at all the transformations, having a big table of results for the Eulers formula. And if they're well designed, there can be genuine student choice because anything a student does will be within an environment in which the teacher wants them to become skilled. And the link back to the socio-ecological is that my belief is that if students start asking their own questions within mathematics, this can become a way of being that extends to other aspects of their lives. And we have some evidence of that. I'll just show you a couple of examples of students' work. This was from when I was a teacher in school, not so you can see the detail, but I wonder if you can see some of the energy or the engagement in mathematics from this child. They are working in a symbolically structured environment. They are writing about what they're doing. They're asking their own questions. And for me, it's almost like a work of art, what they are doing here. So what are the takeaways from this talk? And really, I am closing up now. I feel a socio-ecological turn is taking place in mathematics education. And I hope some of the thoughts earlier might be interesting for you if you're interested in that kind of work. This is an invitation to join our South American network, trying to work with communities on creating a relevant curriculum, and a provocation. I hope the last part is a provocation to ask for yourself, to what extent could you transform your teaching to take place within a symbolically structured environment? I want to acknowledge the work of very dear colleagues, Natalie Sinclair, Amanda Solares, Mark Boylan, Lorinda Brown, and two colleagues in my work in Bristol, without whom none of this work would be possible, Tracy Helliwell and Julian Brown. There are some of the references that I've been drawing on in this talk there. And thank you very much for your attention and your invitation to speak today. So I think, great, I'll stop sharing. So,
yes, we would thank you, Professor Alf, for this excited and challenging lecture. There is a lot of things to think, because especially this moment, this pandemic moment we are living, so it's very interesting to thinking about an approach that could extend and can go to the another ways to think mathematics education. We have some comments in the chat. A lot of people thank you for your nice talk, and I think the people are warming up to make some questions. Great. So I will introduce you one question or one reflection to thinking about. I think this approach, this ecological, socio-ecological term, it's a very interesting way to think how mathematics education can work with another subjects in school, mainly in the primary and secondary schools. But we have to think about the role of teachers in this kind of work. And I don't know if in England, but here in Brazil, it's very common. Certain beliefs and certain agency of mathematics teachers. And these beliefs and this agency, normally it's not congruent with this approach. I think I would like ask you to comment some how we can, as teacher educators, work with mathematics teacher to try to change these beliefs about the role of mathematics in the curriculum, because we need another kind of approach. For example, it's very important to STEM education, for example, to work in this way. So how we can, as teacher educator, work with beliefs and agency of mathematics teachers to do and work in this approach, in this way.
Thank you, Alessandro, for this excellent question. And it is the question of working with teachers, supporting teachers is one that I think is a very important one, and one we are thinking about a lot in Bristol, where I work. Part of my teaching is on a teacher preparation course. And so we have been trying to encourage our teachers to consider socio-ecological questions in their own teaching. And you are right that for some this is very challenging and difficult work, and for some it's work that maybe they think is outside what they want to do in their classroom. And I think maybe that's okay. So I think if people feel uncomfortable, then I think that is okay, because I think there are other things mathematics can do. And some of what I was suggesting at the end around symbolically structured environments would be ways in which it's possible perhaps to stay quite safe within the curriculum of mathematics, and still be trying to engage children in very important ways of thinking, but this time about mathematics. What we also find is that over the last 5 or 6 years where we have been trying to develop this work, we find that each year more teachers are interested in this. More teachers of mathematics are wanting to address socio-ecological issues in their teaching. And what we sometimes offer is the suggestion of starting with something quite small. It's actually very difficult to make a big project. The project I describe in Mexico, this takes a lot of resources to engage in this kind of work, really with the whole community and looking at the whole curriculum. But it's possible to do something for 10 minutes in a lesson on your own. And this is maybe an important starting point. And some of those frameworks of individual approaches, building to society approaches, it's not to say there's anything wrong with doing that. So I think I would say that starting small, starting with things that can happen just within a mathematics classroom, these are both suggestions for ways of beginning. And in terms of the symbolically structured environments, I think teachers do need maybe experiences themselves as learners in this kind of environment. Because in England, often people have been taught in perhaps not a particularly creative way. And so it's like they need to experience for themselves as learners other possibilities.
Okay, thank you. I think in 2000, Steve Lerman bringing us the social turn in mathematics education. Now you are expanding in a way the socio-ecological turn. And now I think we as teacher educators, we have the challenge to make this approach in teacher educators training and on professional development to help teachers, to help mathematics teachers to work with this approach in their classroom. So I think it's a challenge for all of us. Okay.
Yes, for sure.
Raquel?
Yes, thank you very much. It was amazing. We have a lot of expressions of gratitude and compliments on the chat, and I would like to read from Dalvirene. Could you please project from Dalvirene the comment? It's in Portuguese, but she finds the conference excellent because it was not only math education but math education combined with ecology, contextualization, modeling, and she congratulates. There is another question. I think we have 2 more questions. Yes, Luis Torres. Is it possible to do something like this at Tietê River? Would be marvelous if you could get it healthy again. Tietê River is a river in São Paulo city.
Yeah.
And I could say they have similar conditions as this river you showed to us.
Raquel, I think this comment it's a provocation for mathematics teachers and teacher educators, researchers in São Paulo to make some partnership with Alfie and people from Mexico, because Tietê River used to be a very nice river, but nowadays São Paulo, of course, there is a lot of buildings and a lot of constructions. So Tietê River was very, very polluted. So this provocation is for all of us to thinking about to make some partnerships of.
Yes. No, I mean, thank you, Luis, for the comment. And I would please encourage you to, will you email myself or Amanda Solares? We would love to connect with you if you are interested in trying to engage in some of this work, because this is exactly what our network is trying to do, is to trying to link now to other groups in other parts of South America. So we would be delighted to continue this conversation.
Great. You have another question from Daniel Oliveira. He puts, do you think that creating this symbolically structured environment goes hand in hand with the view of the teacher being someone whose job is to point direction or paths which the student can follow?
This is a lovely question. Thank you, Daniel. And I like, well, I will offer you the image that I have, which is slightly different, but it's linked to what you've said. So I guess maybe a traditional image of teaching might be that I'm trying to give you my knowledge from my head into yours. And maybe the opposite is sometimes seen like I am just creating a space for you to explore and discover. I'm sure nobody is really in either of those extremes, I think neither are very helpful images. The image I have of a symbolically structured environment is that as a teacher, I take you down a very narrow path at the beginning, but this path then leads into this space where you can explore. So for instance, with the matrices, the very narrow path is where I am going to teach all of you how to multiply this matrix, and there's no choice about that, and you're going to follow me and you're going to do it in a very direct way. But once we've done that, you then have a skill that opens out into this space where you can explore. The same with the complex numbers or with the Eulers formula. There's no choice about we are going to look at vertices, faces, edges. There's no choice about that. We are going to look at the Euler constant as well. So this is the path, this is the very narrow avenue I take you down. But once we've got there, then we're into this forest maybe where you can look at any shape you want. Because I don't really mind, because I'm not worried about which shape you look at. I'm wanting you to explore vertices, faces, and edges. You know, maybe my aims might be about knowing some shapes and identifying certain characteristics. So it doesn't really matter to me which ones you look at, because I've taken you down into this space where you can then explore just the things I'm wanting you to explore. I don't know, Daniel, whether that makes sense as an image, but...
Okay. So I just want to thank you, the audience, for taking part in this talk, and especially I thank you, Professor Alfcourt, for addressing this very important subject that should be addressed in math classes in all levels. No, it's a challenge, a great challenge for us, math teachers, math educators, and professors, to bring it to the practice. Thank you very much. Thank you very much.
Thank you, Raquel. Thank you, Alessandro. And thank you, everybody, for being here. It's been a great privilege to be here. And I hope that there may be some connections and communications that can continue following this. Please do get in touch.
Yes,
Great.
Thank you so much, Alf. Thank you, Raquel, for this invitation. And I hope the people liked so much this talk, this conversation. Thank you.
Thank you.